All right, I'm going to go over the review for Unit 5. It's 2 pages, or 1 page front and back. Here's the front. Here's the back. So let's go ahead and get started. All right, so the first set of problems is from 5.1, and it's identify the x-intercepts. All right, so the first problem here, remember we're going to look at these numbers here, and we just have to remember to take the opposite. So it will be -3, 0, and 5, 0. So we have 2 values there. All right, B, let's see, we have +9, 0, and again, +9, 0. So in this case, we actually only have 1 intercept. So we don't have to list it twice because it's the same thing. So we could just leave it as just the 1 number. If you're wondering why that might happen, it's because the parabola is going to look something like this, where the intercept actually happens to be the vertex. So it only touches in 1 point. So usually we have 2 intercepts, but sometimes we only have 1 if it's just balancing right on the vertex. All right, number C, or letter C. We have x - 0 and x + 2. Well, the opposite of 0 is still just 0. So 1 x-intercept will be at the point 0, 0 at the origin, and then the other one will be at the point -2, 0. So that's our intercepts. All right, the next part, still from 5.1, is the vertex. So finding the vertex in vertex form, remember we are going to look for our h and our k, and we're going to take the opposite of the number that's in the parentheses with x. So the vertex here will be 6, 4. All right. This one, it doesn't have a k. You don't have to write the +0, but I like to write it. Just remember that there is a k there, even though they don't show it. So the vertex here is going to be -9, 0. And then this last one, it's a little bit of a trick one. The number in the parentheses with x, you can think of this as it's x + 0. So again, that number in the parentheses with x is 0. So the first number will be 0, and our second number will be -12. So there won't be, I don't think there'll be very many tricky ones on the test. Most of them will probably be more like this first one, or maybe the second one. But thought it'd be fun to show you one like C. If that stresses you out, don't worry about it. Just focus on the first 2. All right, let's move on to the next part. This is identify the y-intercept in polynomial form. So remember, our y-intercept is going to be that last constant number at the end. We call it the c sometimes. So remember, our a is the number in front of our x squared, then the b is the number in front of the x, and the c is the last number all by itself. So our y-intercept is going to be the point 0, and then whatever our c is. In this case, it's -80. For b, it will be 0, 48, and for c, it will be 0, 12. So the only thing to remember here is that you're going to put the 0 first. I'm going to zoom out a little bit. When we do our x-intercepts, the 0 comes second. All right. All right, the next thing, we're moving on to 5.2, is completing the square. So for our first completing the square, so first thing, just a quick reminder, I like to always find my half and my square. So those are the 2 things I'm going to find, and I like to write them down. If you don't, that's okay, but it always helps me not get lost and not forget what I'm doing. So for part A, my half equals -3, and my square, sometimes I just draw it that way, is going to be +9, because -3 times -3 is +9. So then f of x equals x squared minus 6x plus 9 minus 9 plus 14. Just to be consistent, I'm going to always put both of them in parentheses, even though I can take this -9 right away out. But that's just going to help me be consistent. I'll always put it in, if you don't want to do that extra step and put it out at the beginning when you don't have to, when there's no a, then you don't have to put it in the parentheses, but I'm going to always put it in just to be consistent. All right, so I can rewrite this now as f of x equals x squared minus 6x plus 9. And on the outside of my parentheses, I have plus my 14 and minus my 9. Everything in my parentheses now is my perfect square that I can rewrite as x minus 3. Remember, I get to rewrite that as x plus my half, whatever my half is. And in my case, my half, remember, was negative 3. So I'm going to rewrite it as x minus 3 squared, and then I'm going to remember to combine my constants at the end. And so I have plus 14 minus 9 is going to end up with plus 5. So that will be my equation in vertex form. All right. I'm going to kind of separate these problems here. Hopefully I have enough space for all of them. All right, part B, let's find my half. My half, I'm looking at half of 12, so half of that is 6. And then my square, 6 times 6 is 36. So I will do f of x equals x squared plus 12x plus 36 minus 36 minus 3. All right. Okay, so in the parentheses, but then I'm going to move that 36 out, that negative 36 out. So then I have f of x equals x squared plus 12x plus 36. On the outside of my parentheses now, I have minus 3 and minus 36. All right, I'm going to rewrite my perfect square here as it's going to be x plus my half, which is 6 squared, and then my constants on the end, that's negative 3 minus 36 is negative 39. So there is my equation in vertex form. All right, one last one to do on this page. All right, this one's a little trickier because my B, now always on these, the C is going to be the hardest one, but the test is usually going to be more like A and B. So if C is getting a little harder, don't worry about it too much. So my B is 5. So half of 5 is going to be 2.5. And then my square is going to equal 6.25. Yeah. Okay. So then I'm going to add and subtract my square. So f of x equals x squared plus 5x plus 6.25 minus 6.25 minus 11. I'm running out of room. All right, we'll move this one out here. Oh, off the page. Okay, and then rewrite my equation. X squared plus 5x. And you know what? I messed up here. This was supposed to be plus my square and then minus my square. Okay, so plus 6.25, and then outside my parentheses, I have negative 11 minus 6.25. All right, I'm going to rewrite my square. My perfect square gets rewritten as x plus 2.5 squared. And then my constants on the outside become negative 17.25. All right. There we go. All right. Let's move on to the back page. All right. So remember, you guys should try these and pause before watching what I do. So let's go ahead and do now. So these ones are completing the square again, but what's different here is that we have an A in front. So we have an extra step. It's going to be an extra step at the beginning and then an extra step in the middle as well. So first thing, our extra step at the beginning is we have to factor that A out. And we factor it out of the first two terms. So that means we divide the first term and the second term by our A. So I'm dividing both of those by A. Those are 5s. And so I don't just get rid of the 5 though. I bring it out front of my parentheses. So by dividing it, I get to bring it out to the front. Okay, so the 5's out front now, and what I'm left with inside my parentheses is an x squared plus 4x, and then my 32, my minus 32 stays outside the parentheses. All right, then I look for my half, and my half is going to be half of my new b, the b inside the parentheses, because that's where we're working. So half of that, my half is going to equal 2, and my square is going to equal 4. All right. So we're going to add and subtract my square, and we're going to do it all in my parentheses. This is why I did it the other way before, is so it kind of stays consistent. So we keep that the same, then we add our square, subtract our square in the parentheses, and then negative 32. So now, again, we want to bring this negative 4 out, but we can't just do it by itself this time. Before we multiply, we have to multiply it by the 5 to be able to bring it out. So 5 times negative 4, excuse me, is negative 20. So it's going to come out as negative 20. Now that 5 doesn't go anywhere. It still stays there because it still is being multiplied by everything else that's staying in the parentheses. So those things all stay in the parentheses, and the 5 is still being multiplied to them. But the negative 4 is no longer in the parentheses, so it has to be multiplied by 5 in order to come out. So we have negative 32 and minus 20 out here. All right, this step is the same. We rewrite our perfect square, but we don't want to forget that our 5 is still going to come down, and then we'll also combine those terms. So let's put it all together. The 5 stays. Our perfect square gets rewritten as x plus our half. And our half is 2. Remember, we can look right here. Or we can also just know that it's still half of that squared. So x plus 2 squared. And then combined our constants on the outside, and it's minus 52. So it does take a couple more steps. So you're going to need a little bit more space. And you just have to remember to pull the a out at the beginning. And then make sure you distribute it in this right here. You have to distribute it right here in order to get that negative term out of your parentheses. All right. Let's divide this space up. See if I can make some room here. Okay. So again, our first step is going to be to factor our a out, which means we're dividing those terms by our a, which in this case is negative 2. I think I'll save some space if I don't write f of x each time. So I'm not going to write f of x each time, but I'll put equals. So the negative 2 doesn't go away. It just comes out front of our parentheses. So negative 2 x squared. 16 divided by 2 is negative 8. And that's my x. And the 19 stays out here. All right. My half is going to be half of negative 8. So my half is going to equal negative 4. And my square will equal positive 16. Okay, add and subtract my square. Make sure you don't lose this a, this negative 2 out front. You don't want to lose it. So make sure you always keep it in every step. I know it's not fun to write it every time, but if you get lazy and stop writing it, you're going to get lost at the end when you're going to miss it at the end maybe. I've seen it happen many times. All right, so we want to get this negative 16 out, so we got to multiply it by the negative 2. Negative 16 times negative 2 is going to be positive 32. All right, so we rewrite it. We have negative 2 still. X squared minus 8x plus 16. That's what's still in my parentheses. Outside my parentheses, I have plus 19 plus 32. I rewrite my perfect square, bring my 2 down, and combine my constant. So I'm going to do all of that in this next row. So the negative 2 stays. My perfect square is x minus 4 squared. Again, remember I can look at my half or just see half of what's there. And then my constants put together is, let's see, it should be 51, positive 51. And if I make a mistake, please let me know so I can fix it. All right, last one. And I am not giving myself enough room here. So that means you might not have enough room. If you need to get another piece of paper out, then I'm sorry. All right, first step, we are going to divide. Remember, we're going to factor out a, so that means divide those first 2 terms by a. So the a is going to come in front of our parentheses. We have x squared, and then it'll be minus 3x minus 27. And again, they gave us a b that's not going to be fun. Our b is negative 3, so my half, I'll spell it out. My half is 1.5, and my square then is 2.25. Okay, so we're going to add and subtract that square in my parentheses. X squared minus 3x plus 2.25, and especially not fun if I don't have room, minus 2.25. That's all in my parentheses, and then minus 27. All right, I want to move this one out, but I got to multiply it by 4. So 4 times 2 1/4. Well, 4 times 2 is 8, and then 4 times 1/4 is 1. So it's going to come out. It's going to be multiplied together. It's going to be negative 9. All right, a little bit more room down here. So it's 4 in my parentheses, x squared minus 3x plus 2.25. Outside my parentheses, I have negative 27 and negative 9. All right, rewrite my perfect square. It is x plus, oh, it wasn't plus. Good thing I double checked by looking at my half. This is why I always look at my half. My half was supposed to be negative 1.5 because my b was negative 3. Okay, so x minus 1.5 squared. Don't forget the 4 in front. And at the end, it will be minus 36. All right, there we go. Phew. All right, we are done with completing the square. So those take a long time, some of them. There's a lot of steps. Go slow, take your time. I know you guys can do it. I've seen you do it on the quiz, so just take your time one step at a time. Don't forget all your steps, especially when you have an A. All right, we are going to move on to the word problems. You guys did great at these, so just another review. All right, so let's see. A ball is thrown with an initial upward velocity of 48 feet per second from a height of 160 feet. What is the ball's maximum height? So I'm going to underline that. First of all, it's my question, but also I'm going to highlight it because maximum is my keyword. And how long until it hits the ground? Well, there's another question. How long until it hits the ground? And hitting the ground is another kind of key, another clue, hitting the ground. All right, and then they give us the equation. All right, I'm all over the place here, sorry. All right, they give us the equation right here, where h of t is the height and t is the time in seconds. All right, and you guys you're familiar with these, you're good at these, so just practice doing it on Desmos. So I'm going to go ahead and get to Desmos. All right. So my equation is, and remember we always enter these as y equals instead of h of t. We don't put h of t, we put y equals, and then we use x instead of t. Otherwise, Desmos gets confused and thinks we're doing something different. Okay, so negative 16x squared plus 48 plus, oh, backspace, 48x. It's always good to double check. Plus 160. All right, so that is my equation. I'm going to give it a little more real estate here so we can see it. Okay, so remember we wanted to find the ball's maximum. Right over here, we're looking at the maximum. So we are going to scroll to the very top of my graph. I can zoom out, scroll, and click on it. And it will tell me that the maximum, my vertex, is at 1.5, 196. Okay. So the vertex my vertex is at 1.5, 196. All right. But we got to actually answer the question, and the question asks for the maximum height. So that is the 196 because the y value is our height. So to answer the question, the maximum height is 196 feet. Okay, that was one question. Now we're going to go back for the other question, which is how long till it hits the ground. And the clue there is hits the ground, and that means we're looking for the x-intercept. So the x-intercept, let's go find that. Scroll all the way down. I know it's harder on the Chromebooks too. Oh, I scrolled too far down. That happens sometimes. If you ever get lost, if you hit the button that looks like a little house up on the top right corner, it will take you back to kind of your origin, and that helps. So our x-intercepts, we have two. We have one that's to the left of 0 and one to the right of 0. The one to the left of 0, that happened before time started. So we're not going to consider that one because that one doesn't really exist. It happened before time. So we're going to click on the one after. That is at 5 seconds. So our x-intercept is at the point 5, 0. So we want to know the time when it hits the ground. Well, hitting the ground means the height is 0. So we want to know the time, which is 5 seconds. So our answer to the second question is 5 seconds. So those are two different questions, two different answers. All right. So let's move to question B. We'll get rid of that equation because we'll have a new equation. So a water balloon is dropped from the top of a building. What is the balloon's height after 2 seconds? And then how long until it hits the ground? They give us the equation. And again, same thing. H of t is the height and t is the time. All right, so I'm going to put my equation in. Y equals negative 16x squared plus 576. All right. So first of all, they say, what is the balloon's height after 2 seconds? So they're giving us an actual number, and that number is a time. So I'm going to go ahead and write that other equation. My time is an x. So I'm going to say time x equals 2. So now I'm going to see where these two lines meet. And I'm going to give myself some more space. Well, I'll give you some more space to see too. Let's see where those two lines meet. Okay, looks like they're getting close right about there. There we go. Okay, so those two lines meet at 2, 512. So that means at 2 seconds, the parabola goes through the point, or in other words, the ball goes through the point 512 feet. So at 2 seconds, the ball is at 512 feet. So what is the balloon's height at 2 seconds? It is 500. Get my pen back. 512 feet. All right, second question, how long until it hits the ground? You guys know that. That's going to be our x-intercept. So let's go find our x-intercept. Okay, so we'll scroll back down to our x-intercept. Hopefully I don't scroll too far again. I'm going to get rid of my green line. I don't need that one anymore. I could have hit the home button. That would have been easier, huh? Okay, there we go. Right there at time 6 seconds. So our answer to that is, well, the point is 6, 0. We don't have to write that, but might as well. And at 6 seconds is when it hits the ground. All right. Now let's do the finance equations, the finance problems. So this company is making toasters. A toaster company has determined that its weekly cost function is this equation, where C is the cost per toaster and X is the number of toasters. How many toasters should be made to minimize cost? So our keyword there is minimize. So we're going to be looking for a vertex. So let's go ahead and graph that and find our vertex. So we have 0.05 x squared minus 8x plus 350. And I didn't put y equals. You don't have to put y equals. I probably should just because I think it's better. Just like sometimes they don't put f of x equals. It's nicer to put the y equals, but if you don't, it will still work. Let's go ahead and put it there. Y equals 0.05 x squared minus 8x plus 350. Okay, just making sure my equation looks the same as the problem. Now I don't see a parabola, so I'm going to have to, let's get some more space. I'm going to have to zoom out until, there it is. Okay, I found it. All right, I found it. Let's find the vertex. The vertex is at the point 80, 30. So if you remember, the 80 represents the product, which is toasters, and the 30 is going to represent the cost. So when we make 80 toasters is when the cost will be the least, and it will be 30 at that point. So let's write our answer. So how many toasters should be made? They should make 80 toasters. Make sure you always answer with words on a word problem. Toasters, 80 toasters, and the minimum cost will be $30. All right, shoe company. So a shoe company has determined its profit function for its newest shoe style is P of X equals this. So P is the profit and X is the number of shoes that it makes and sells. What is the first break-even point for these shoes? So we have two questions here. Let's see. The first is the break-even point, and then the second is the maximum profit. So break-even point, that was a clue word for x-intercept, because break-even point means you're making $0. So 0, that's an x-intercept when you're making, so 0, if your profit is 0, that means your y is 0, so your x-intercept. And then our maximum profit, that's going to be our vertex. So we're going to look for both of those points on this equation. So let's go ahead and put our equation in. Y equals -15 x squared plus 2,250 x minus 81 with 3 zeros, 0, 0, 0, 81,000. All right, and I'm going to make my graph bigger so we can see it. Okay. Let's zoom out a little bit. So let's find this first question was the break-even point. So let's find the break-even point. So it said the first break-even point. There's two. There's two x-intercepts. They're here. Wait, no, where are they? Yep, right there and right there. So when they make 60 shoes, they break even. And then again at 90 shoes, that they break even. That meant that they were losing. They hadn't made a profit yet until 60 shoes. Then they made a profit, and then at some point, once they made 90 shoes, they started losing money again. So they're only making a profit if they make somewhere between 60 and 90 shoes a week. If they try to make more than 90 shoes, it costs too much. So those are their 2 break-even points, but the question was, what is the first break-even point? So the first break-even point is 60 shoes. So that first question would be making 60 shoes. 60 shoes. Okay. And then the second question is, what is the maximum profit? So maximum profit, we're going to find vertex. So go scroll up to the top. Ooh, it's way up here. Keep scrolling. There it is. Okay. So our maximum profit looks like it happens when they make and sell 75 shoes, but they didn't ask how many shoes. In this case, they just want the profit. So our max profit there is, it's in dollars. It's going to be $3,375 is the max profit. All right. All right, so I also, the answers for this are also on Canvas if you just want to see the answers. And I can take screenshots. I will put screenshots of this work too if you want to see this as well. Good luck on the test. Thanks. Bye.